Find the answers to questions you may or may not have asked yourself here at Science, Conversations on Cognitive Science, hosted by Elisa Palmer and Sönke Löw.
In a previous episode, we already talked about the combination of artificial intelligence and fighting climate change, but since that is a very big topic and especially the combination of those two is very important for the future, we have invited yet another guest, and we like to welcome Cornelius Wolff.
Hello, thanks for having me.
And as always, at the beginning of an episode, we play our short welcome game where we really want to get to know who you are and, well, learn a bit more about yourself or about you. I give you 5 sentence beginnings and ask you to finish those spontaneously and without overthinking it too badly. The first sentence is, as a kid, I always wanted to be.
First an astronaut, then an astrophysicist, then an architect, and then exactly what I do right now.
Interesting. I was just thinking because it started quite spacey.
Well, I realized like when I was 8 years old that you spin around quite frequently in space.
Mm-hmm.
And that if I do that on a chair like 2 times, I basically get so sick that I have to lie down. And that was the end of that story. Then it was like the next thing was astrophysicist, just because that's quite close. And then I realized, getting a job with that might be difficult at times, and it's also quite hard in terms of a study program. So then it was architecture, and I honestly don't remember what stopped me from doing that. But then, yes, like when I was 14 years old, I was like, information systems, that's where I see myself. And later I went over to cognitive science, but yes.
You thought about that quite early. Okay. If I was an emoji, I would be.
That's a hard one. The one with the red hat, but with like this funny face. I don't know which one it is.
The devil or the angry one?
No, the like. Wait, I can show you.
Yes, please. Oh, so that one that looks a bit drunk-ish. The next sentence is, my favorite thing to do on a day off is.
If I have a day off, probably spontaneously traveling to the sea.
Which sea exactly?
Baltic Sea, not North
Nice.
Sea. Baltic Sea is much better. Everyone offended.
Right now, I'm most fascinated by.
AI and like biologically inspired AI.
And how far?
Just because from what I see, it has a lot of potential, but I'm still not able to totally wrap my head around all of the core concepts, which means there's still a lot to learn for me. And like if I have this mysterious blob of knowledge which I can learn, but I don't fully understand it yet, that's generally something that fascinates me.
Yeah, I see that. I know it's time to call it a day when
I start to get dizzy at work.
Just at work or also at home?
No, at home, I don't know. I can just lie down and stop it and work from there, I guess.
Okay, thank you so much for your answers. We've already heard that as a kid you knew quite early that you want to do something with informatics or computer science, but you didn't start with cognitive science in your bachelor's. So can you maybe tell us a bit where you started your studying, your scientific journey, and where you are at right now?
Well, I started with information systems, though I believe the German term, like which translates to economics, like management and computer science, describes it much better, because I basically had the business management courses and computer science courses. My motivation basically was I wanted to do something with computers and program, but I also wanted to interact with humans. Not only computer science, just coming from very, very basic stereotypes there when I was like 18 years old. But yes, so that was like where I started off. But I realized during my studies that I am leaning much more to the programming and also to the AI side. I still don't regret that I started this study program because I just learned a lot, like in terms of theoretical management skills, which sounds incredibly boring, and believe me, it is to learn, but it's also quite useful.
Yeah.
But then I realized that a lot of people who study that program end up being a consultant, and I didn't see myself being a consultant at some point, or maybe I will be, but at the time I didn't. So I decided to go with this weird little passion for my 5th and 6th semester, which was artificial intelligence and also psychology, and switch over to cognitive science in Osnabrück. So yeah, and that's how I ended up being in cognitive science. In the meantime, I also worked at the distributed systems research lab, and then switched over to the German Research Center for Artificial Intelligence, where I am at right now as a junior researcher.
And well, I think we're going to talk about your work at the German Institute for Artificial Intelligence, or, well, the short abbreviation in German is DFKI.
Yes.
So I think we will use that from now on because it's just less bulky.
Yeah, some people say DFKI, which sounds even, I'm not sure which sounds worse, but yes,
Yeah,
DFKI
I would stick to the German version, DFKI.
Yes,
so it's
definitely
an abbreviation for German Institute for Artificial Intelligence, using the German words. So for all our non-German speakers, DFKI basically stands for German Institute for AI.
Yes.
What are you doing there at the moment?
Mostly I'm working in the Green AI Hub. I'm also in some other projects involved a little bit, but not like mostly 90% is the Green AI Hub, where I'm responsible for developing prototypes and proof of concepts for the industry so that we can show those proof of concepts to the industry and show them, hey, look, this is a cool thing you can do with AI in the context of sustainability. Yes, so that's kind of my work description next to all the other stuff I'm doing there.
So you've already hinted that Green AI has something to do with sustainability, but are there other aspects that people should know when they hear the term Green AI?
I mean, yeah, I think Green AI mostly divides into like these two very important subtopics. The one is AI for sustainability, which basically is about using AI to make existing stuff more sustainable. And the other side is sustainability of AI. Like, I think this became a more popular topic with like ChatGPT and so on, when there were like articles and popular newspapers about, okay, look, ChatGPT will use so many resources in the future. That's problematic because AI in itself also has a carbon footprint. But like those are the two major coins, which are oftentimes also connected, but those are the two sides to sustainability and AI. And yes, I think those are the two core concepts. And then a lot of other stuff gets involved, like rebound effects and so on, which also can't be ignored.
Okay, and which of these two are you working on more, or is that maybe like is it that convoluted that it's you work on both aspects?
I'm in the project in general, like just to maybe explain how the project is set up, because it's funded by the German Federal Ministry for Environment Affairs, and they have a pretty strong interest to use AI for sustainability, going into small and medium enterprises and using AI to make their existing processes more effective. Like that's what this project is mostly about. But at the same time, because like I'm not part of the team that works with the industry, I'm part of the team that works for the proof of concepts. And we also have other project partners which do take a look at, okay, guys, you want to deploy AI in this company. Does AI reduce the carbon footprint in such a way that the added carbon footprint by the AI model is actually worth it? Like in some instances, that's not important at all. In most instances, honestly, which people I don't I don't think they expect. But still, that's something we have to look at. So for myself, it's like a 50-50 split. When it comes to the prototypes and proof of concepts, I also want to show that using AI doesn't always lead to gigawatts of energy consumption. It also can be very, very small and not that energy intensive. So in this context, I'm moving on the sustainability of AI side. But at the same time, I also like showing that AI on its own doesn't need a huge energy consumption is not a good selling point to a company because, okay, great, you can use AI without a lot of energy, but what is the AI actually doing? So you have to cover both sides there. That's kind of the takeaway, I guess.
So trying to balance the use of AI for company with the carbon footprint this AI will have on the overall carbon footprint of the company.
Yeah. Yeah, but I think what's important to point out in this context is that there's this general perception that AI uses these huge clusters of GPUs and that like of graphics cards and that it takes a lot of energy and a lot of effort to train those AI models. And I think this notion largely comes from ChatGPT and large language models in general, where this is certainly a problem. But for most industry AI, we talk about very small models, sometimes statistical learning, which is trained on your average laptop. And they are calculating the carbon footprint of the AI model can oftentimes just be ignored because if I train it on my laptop, like, okay, how much of the carbon footprint is the AI model that I'm training and how much of the carbon footprint of my laptop is the mails I'm checking in the meantime while it is training. So I think this notion is it's very important to not only have this one-sided perspective, okay, AI models use a lot of energy and are very carbon intensive. I think it's important to point that out.
And in your work, like, you don't just calculate like the carbon footprint of AI models, but you also create the AI models, is that right?
Yes. Like when we work with industry partners, they approach the project and say, hey, we saw that Green AI Hub project, can we join as an industry partner, like as a pilot project? And then we go through this acquisition phase. And once this all has been figured out and we are confident that the AI model they require actually reduces the carbon footprint in their company, then we go ahead and do like the complete development of the AI model, the deployment, the evaluation with the company together in like 6-month projects. So yes, we do the complete development project for these AI models, but we also evaluate them in terms of resource efficiency.
And speaking of resource efficiency, that's like a different aspect, right? Because like on the one side we have like the carbon emissions, but
yes.
On the other side, like there are other resources that are limited and maybe expensive. So there's more than just the carbon footprint aspect of it.
Yes, definitely. I mean, that's a huge point. Like I said earlier, it's not only about reducing the carbon footprint of the AI model itself, but also using the AI model to reduce the carbon footprint in other projects and reducing the resource intake of maybe the entire production process in a factory. When companies come to us and are like, okay, we have this project where we want to use AI to make our processes better, then we have to ask, yes, but does this reduce your energy, not only your energy consumption, but maybe also other resources that you might use? And also on the AI side, like you said, there's not only electricity, but there's also, you have to buy the GPUs, you have to see if you can use an existing infrastructure. In some companies, they don't even have a basic database server because like it's a very small company, maybe they only have like 5 local machines. But for a lot of AI models, you need to have like a centralized database. And then you have to buy those servers as well. And all of that has to be included in the calculation, whether it is actually worth it from an environmental perspective to deploy this model or from a resource efficiency perspective.
I would like to take a small step back because you've mentioned that in the most context where people talk about the use of resources is ChatGPT or those large models.
Yes.
Can you maybe, especially for listeners who are not that deep into those topics, explain why they are so resource demanding and why it takes so much energy to calculate or to work on those models?
I mean, first of all, I think there are two sides, again, to the carbon footprint of these large language models like ChatGPT. The first point is the training time. Those models have to be trained. And again, like, first of all, I think the name gives it away, large language models. Those models are incredibly huge. Like in terms of gigabytes, sometimes we talk about like 50, 60 gigabytes for like just in terms of storage space for one model.
Maybe
or
can you
even
give
more.
a reference how much that is? Because if a person has never really worked with gigabytes and bytes, it might just be a number where they are like,
Your
whatever.
usual USB drive like will struggle with that. Like those models just physically can be very huge, and all of this huge storage space is taken up by these artificial neural networks, and training those is incredibly intense. You train those by basically, in terms of large language models, showing them existing text bits, like from the internet, from Wikipedia, and so on. And by showing those texts to the AI model, it learns to predict. If you give it a sentence, then it learns to predict, hey, okay, the next sentence is probably going to be this and that. But until it learns that, you need an incredible amount of data. Basically, those models are trained on a large portion of the existing internet, like Reddit, Wikipedia, and so on. And just imagine going through all Wikipedia articles there are. So that takes a lot of time and resources for an AI to go through that multiple times and learning all of those different connections which are part of the data set. So yeah, that's like on the training side, which is incredibly resource intense. But then there's also the inference side. I think when you read articles in like popular newspapers, it often focuses on the training side because that's easy to calculate. Like, okay, you have so and so many servers, they take so and so much energy, then it's easy to calculate, okay, it took probably that amount of CO2 to train those. But once it comes to the deployment, like once you actually start using models like ChatGPT, this tracking becomes a lot harder because most systems work by scaling automatically with demand. Like the more users it uses, the more servers are added, just virtually. So calculating the CO2 footprint on the usage side is also something we are working on right now, like developing tools for that, because that's something that's oftentimes being ignored, and it's also hard to put a number on that. And those are like the two sides when it comes to large language models and sustainability. That's very important to like look at both sides, but all of this leads to an incredible amount of energy usage in large language models like ChatGPT.
And coming back to the there are small companies that use the Green AI Hub. For them, it's also like both aspects, but probably like the smaller the model, the more heavier it is maybe on the training side, or is that maybe a wrong intuition?
I think, I mean, not generally wrong when it comes to large language models. Studies have shown that using smaller models, if you train them longer, then they might end up with the same performance as larger models. So then the training process gets more intense, but the usage process profits from using less energy. Like when it comes to large language models, your intuition is right. But apart from that, the smaller the model, the less energy it consumes at every stage. And yeah, so that's, again, really important to point out that these small companies that use very small AI models, those usually don't take a significant amount of energy. Like it's not even like it's not even worth calculating, in my opinion, in a lot of cases, because if you have it on basically the equivalent of a USB stick where your AI model runs, okay, then it's just background noise for the company, but it might save so and so many kilograms of CO2 that the calculation becomes very one-sided there, and it's definitely worth it. But those smaller AI models, they don't take that much time to train, and they don't take that much energy to run afterwards. So yeah, when it comes to large language models, your intuition can be right, but everything else, basically the smaller the model, the smaller the data set, the easier not the easier it is to train, but the less energy it takes training it.
Mm-hmm. And the companies that are applying to this Green AI Hub, they're all in the production industry, or?
They are all over the place. That's the nice part. We basically have, like, from the Ministry for Environment Affairs, they just said, okay, you are targeting small and medium enterprises, but we don't really care which ones. It's mostly from the production, like production industry, like they produce some physical good, but they don't have to be. The project is pretty flexible on that. But the only requirement is that it's a small or medium enterprise. We don't target large companies with that project.
I was just thinking, to me, it often appears like as AI gets more and more complex, it also gets more resource consuming. But is that actually the case from your experience? So can we say that in general, all AI will just use more energy resources, or are there also workarounds how to reduce the...
I mean, I can somehow give that question back, like, please define complexity. But besides that, I mean, if you look at complexity as the problem you are tackling is getting harder and harder, so you'll need more and more data, then yes, the more complex the problem is you want to solve, in general, the more resource intense the AI model is. That's not always true, because in a lot of cases you can, like, just use your own brain and build use a smarter architecture. And if you have a very well-designed AI architecture, it also might be able to solve a complex problem quite easily without having to use vast amounts of compute. But in general, yes, the more complex the data set or the problem in general, the larger the model, and therefore the larger the energy footprint of this model.
Okay,
yes.
But one way to reduce the footprint again would be trying to create algorithms that use less computational power.
Yes, and also the current development of graphics cards, which is like basically the hardware that most AI models runs on, is also getting more and more efficient. Like when you want to run a modern large language model of the hardware from 2015, it's a lot more resource intense than it is right now. And I think so, like, over time, more complex models also need less energy, just because we make so much progress on the hardware front. And that's also like in the 10-year time span, there's also like other developments on the horizon, which will also change the energy consumption, hopefully a lot to the better. Let's wait and see.
And apart from the energy consumption, there are also like maybe other trade-offs that had to be taken into account, like maybe the model then, I don't know what the output is, but it has something that is maybe more expensive. Is that like that the last call is on the side of the company you're working with, or is that maybe something that never occurs, so there is no other real trade-off?
What do you mean in terms of expensive? I'm trying to figure out a scenario where that, like a specific scenario where that might happen.
I'm not sure how you like what the inputs and outputs for your models are, but maybe like if you see like we had an episode, there was something about fertilization of plants, and the idea was to calculate how what chemicals should be used to fertilize these plants. And then you find out, oh, if we use the AI model, then it's more efficient because we then have like a better intuition of how much we need of which chemical. But then maybe it turns out that one chemical is needed a lot for the model, or like the model says, like, do we need a lot of that? And this is a very expensive chemical. Then they say like, okay, yeah, that's a nice model, but we don't actually need that because it's too expensive for us.
Yeah, on that front, we largely rely on the companies that work with us. In most cases, they have a rough idea of what they want to achieve. And we just, on that side, we have to trust them that they know what they need and how expensive it is in the end. But like that's not a case we had before, to my knowledge. But yes, on that front, we just like the companies have to say whether it is worth it for them or not. Also from like not only an ecological but also from an economic point of view, because like even though it's called the Green AI Hub and it's about reducing the energy consumption, resource intake in general. Obviously, there are also like a lot of economic factors that have to be considered, and we can't just be like blind to that. Using AI in this context might provide a big advantage to some companies when it comes to the business side, because using less energy, using less resources in general is also very, very nice economically. But also if like in your scenario, if the AI decides or recommends using more of one very, very expensive resource, it might also be a disadvantage and might lead to the company not using the AI model. So yes, we can't just disregard general economics for the companies, and also have to look at that when we start developing the model.
So how does such a process usually look like? How's the process?
I think, first of all, it largely depends on the company. But in general, like I said earlier, the companies approach us. We have like this website, and they can just go through the website and apply to be a pilot project for the Green AI project, which is nice for them because then a lot of resources are funded by us, by the project, and they don't have to put much or any funding up on like for themselves. But they apply to us, and then we go to them and discuss this idea they might be having or the general setting with them, and see if that's a project that's worth tackling, and if it's a... So yeah, after this is like, if we say, okay, yes, that looks realistic, we can do that, it also is good on the environment front, then the project starts off officially, like 1 or 2 months later, depending on the project. And then most of the time, we have to figure out where to get the training data from. Like, I think in a lot of people's minds, being like developing AI models, you are constantly involved with, okay, I have this fancy neural network and it will change the world, and it is training something and learning, and then you can look at nice training curves and have fancy plots all the time. While in reality, it's mostly about, okay, where do we get the training data from? Like, do they have the training data? Do we need to generate it ourselves? If they have the training data, can they just hand it over to us? Is it in a format where we can actually use it? This entire process of figuring out the data input and so on, that takes a huge amount of effort and time, which is something that has to be on people's radar when it comes to AI projects in general, I believe. I feel like I said, people have this notion of the AI just learns on whatever you give it. But in reality, the process is more about, okay, we have the 6-month window. The first few months are only about figuring out the potential training data, or what exactly is it that we want to build here. And then building the actual model oftentimes doesn't require that much of time. It's much more about figuring out the data beforehand. That's part of the process. And yes, after that, like once we figured that situation out, we start building the model, which takes surprisingly little time. And after that, the next like huge step is the actual deployment, like taking this AI model, which so far only existed on our local machines, like on our local laptops and so on, and bringing those into the company and integrating that into their workflow, setting up the servers for them, and also making it maintainable, meaning it's not about like, okay, you just dump this computer into the company and be like, there you go, now you have AI, good luck, see you later. They also have to be able to maintain this AI model. That's incredibly hard for like some of these small and medium enterprises, because they might have an IT department, but then it's not that big, and you might have no one in there with AI experience. And some of like people are extremely skeptical of AI in general. So you also have to get them on board with maintaining the system, explaining it to them, creating the interface in a way that the companies are able to properly use it and are not constantly confused by what is happening on the AI server. Or even like if it just works on its own, which is rarely the case, then also telling them, please don't trust this AI blindly. That's also like very important in general, like teaching the people who work in these companies how these AI model works and how they can be maintained. It's like, in my opinion, next to the data acquisition process, the other very big step that's very important, the entire like deployment process and maintenance afterwards.
Are there usual misconceptions people have about AI and the usage of AI?
Usual? Not really, but a lot of wrong conceptions exist out there. There's this one side of, okay, AI is just overhyped and it will not do anything here. So a lot of skepticism. Okay, because people also have this notion of ChatGPT, and then you are producing, I don't know, some part for a car, and you're wondering, okay, what could I use ChatGPT for? And then you have to explain to those people, yes, AI, ChatGPT might be the most popular use case at the moment, but it's not that all that AI is about. So you have to challenge like this perspective of them, to tell them, yes, AI can actually do real things. It's not about generating nice pictures and chatting only. But then there's also the other extreme, like people being like, okay, now AI comes in and then everything's perfect. Then we live in an economic wonderland where all of our problems have been fixed by this wonderful AI that nobody understands, and they will be better than all of our humans doing this job right now. And it's like, first of all, you guys, you know what this AI is trained on. It's trained on your human-generated data, so having AI that outperforms humans on those tasks might in a lot of instances be nearly impossible, because how would it learn something that even humans haven't figured out? And also just like managing expectations there. Yes, AI can do very nice things, but it also has its own problems. It's never perfect. You have to always question what the AI is doing, and you still use your own brain when dealing with those results. And not like the AI is not this magical wand that will fix everything. But I think like both perspectives, like I encountered myself and exist out there. So yes, it's a wide range of expectations there.
You talked about like the process that the company goes through, but can you maybe give a typical timeline if there is any, or does it depend on how big the project is?
Usually, like we have the starting point for like those projects or those companies. When they approach us, they will be slotted into certain batches, like batch 1, batch 2, batch 3, and all of those batches have like the same starting point. Like, for example, if you would apply right now to the Green AI Hub, then your project might be part of the next batch of projects that we start. This might take like a few months until this project actually starts. And then one project in general always takes 6 months, though there's like some wiggle room to make it a bit longer or shorter if it's needed. but that's generally the timeline of like a few months until the project officially kicks off, and then 6 months for the actual project.
Nice. It sounds like your idea you had before choosing your bachelor's, that you wanted to work with people, really like plays into this, because like I'm not sure how much you are concerned with like the actual deployment, but it sounds like this is something where there is a varying group of people that you have to interact with and always like adapt to where they are coming from.
Yeah, on that front, I think like for me it was a really good fit, because on the one hand I'm still sitting there in my booth programming on my own, developing like nice interfaces, little AI models and so on. On the other hand, like you said, I have to interact with a lot of different humans, like also just other students who write their thesis in our project, which is also possible. We with other companies, when we like go to them and talk about their projects. Yes, I think like having both sides being part of my job is something that I appreciate a lot in my day-to-day.
In one interview we had earlier, AI was in a way tackled as something that can really contribute to climate change and climate protection. Since you are more concerned with the sustainability aspect of AI, would you generally agree, disagree, or what's your opinion on, well, the impact of AI on climate change?
I think it has a lot of potential in all domains there, honestly, and not only like on the positive and on the negative side, because we talked about ChatGPT earlier. Those large language models, the extended usage of those will have an impact on our carbon footprint. There are estimates that like a significant percentage of energy consumption in 10 years will be just for AI models. So that's like, especially on the negative side. But also on the positive side, for the companies, just reducing their energy consumption, for maybe cleaning up, like if you want to clean the ocean or something, there are probably nice use cases for AI there as well. But also just for descriptive tasks. Like I know that I think it was DeepMind. They developed a very, very nice and well-functioning predictive model for just weather in general. That was like not climate, but on the short term, like a weather model. But I think AI also has the potential to lead to some very interesting findings on where climate change is actually going. Like what are the current impacts of climate change, what might be happening in the future, and so on, just on the descriptive side when it comes to climate change. I think AI might also have some potential. But I think it's like I said, on all sides, it's neither good nor bad. It's just, it can contribute a lot to fighting climate change, but it also has its own problems.
A bit earlier, we talked about how far the carbon footprint of AI might change across or over the next 10 years. And I was just wondering, right now we are mainly using the graphic cards. Is there any follow-up thing that will be used? Will we always use graphic cards? So what's the perspective there?
I mean, yes, for the, I think, short-term foreseeable future, graphics cards will be the way to go, and they will get more efficient and need less energy. But in the future, I think it's perceivable that other architectures might take over compared to the classical graphics card architecture. Like what comes to my mind is neuromorphic hardware, which is something we are also working with. The idea behind neuromorphic hardware is basically that, okay, hey, maybe let's not use those classical calculation architectures, but let's try to resemble what an actual biological neuron does much more closely in the hardware. And that's also something like that's an early development now. You can get like first developer kits for your own testing. At the moment, it's not very economical to use those, because you have to pay an enormous amount of money just to get your hands on a chip that can't even perform the basic AI tasks that your modern day smartphone can. But those chips, because they are much closer to the biological example, they also use drastically less energy. I mean, just your brain like works with how many watts? I think like 30 watts of energy, like equivalent.
Yeah, I think possibly.
And getting closer to this biological example reduces the energy consumption a lot. And that's something that's like actively in development now. We have to see if it really takes over in maybe 10 years or so. But in general, that's like a very interesting way to go. Also because I think it's just curious. Originally, this neuromorphic hardware was developed by computational neuroscientists to explore how the brain works, how those neurons connect, and get better models of actual neurons and make the calculation on them. But now industry came in and was like, hey guys, we also see that takes less energy. Can we maybe use that for our own stuff and reduce the energy consumption there? And yes, that's something that's fairly interesting working with right now.
Can you maybe explain how far those chips are more oriented on the human brain compared to classical graphic cards? Because I assume you're not taking neurons from the human brain and put them into a graphic card and be like, now work there. So how does that work actually?
I mean, there was this paper from, just to dive off a little bit there, in Australia where they just put a lot of biological neurons into a petri dish and trained it to play Pong. But that's not what's happening here. What they are basically doing, like a classical graphics cards, you have these artificial neural networks, and those are huge, like mathematically complex things that need to be calculated. And neuromorphic hardware, on the other hand, says, okay, just like roughly, that's like, if someone's listening from the neuromorphic community, they will probably like yell at their smartphone right now. But what you basically attempt to do is that you actually don't really calculate those neurons, but you simulate how those neurons work in hardware by saying, okay, we connect those different neurons in the hardware and say we have something like 256 to 1024 neurons in there, and we connect them just physically to each other and simulate like action potentials and so on in the hardware itself. And so therefore we actually don't have to calculate it. We can just use voltage, like classical electricity, to model the neurons. I hope that wasn't too technical.
No, I understood it.
I didn't. Like my brain right now is just trying to make up a human brain, which looks like a computer chip, but I'm still pretty sure that's not the way it works.
No, but like your neurons in your brain and in an artificial neural network, those are just like a bunch of tiny things that are connected to each other. And they are connected to each other with different rates. Like some connections are very strong and some are very weak. Like everything in that's just how your brain works.
So like this classical picture of the more often you take a road, the stronger the road gets.
Yes, exactly. Yeah. And you basically try to model that in the hardware itself. That having, by using electricity like your brain, and having like stronger connections between some neurons.
And does stronger connection mean more voltage or just more wires in a way?
That depends on the specific architecture.
Okay.
But yes, generally it means that from like one neuron to another, the connection is just stronger. Like they fire more often on that connection. Okay. Fire, this means they more often send data to each other, or information in general.
That makes it a bit more clear to me. Thanks.
Nice. Earlier I had the impression that it was mainly like artificial intelligence what you're concerned with, but we now heard that there's also computational neuroscience. Are there more fields of cognitive science where you think like this project really benefits from a background of cognitive science?
I mean, I like in the wider sense, psychology, when it comes to the entire human aspect of AI, those AI models always interact or sometimes even take away jobs from humans. I mean, let's be realistic. In some instances, that might happen, that the AI which we deploy reduces some measure of resource intake and so on. But this might be done by, okay, damn, now one job doesn't exist anymore. And also, like I said earlier, a lot of people are very skeptical of AI or are just too hyped about the potential of AI. And like having this psychological background of knowing how to communicate the realistic expectations in a way that those people are still open to the concept of AI while not being like very disappointed or again overhyped is, I think, something that's like very useful but in AI in general, not only in the Green AI Hub.
We are now coming to the end of this conversation, and I think it was quite filled with information and a lot of different insights. When a person has listened to this episode and now feels a bit overwhelmed, what should they definitely take home?
I think the most important message is that AI and sustainability is never a one-sided story. There's always a trade-off. There will be a lot of articles out there saying ChatGPT will ruin the planet because of its energy consumption. And there will be articles who claim AI will save everyone because it can automate all tasks away and we will live in heaven. But I think the truth lies in between, and AI in the context of sustainability has a lot of potential, but also a cost attributed to it. And I think people should keep that in mind when reading articles on that in the future, that it's not a one-sided story.
Yeah, thank you so much. With that being said, we now come to an end. Thank you so much for coming here, taking the time to talk to us and introducing the whole topic of green AI to us and our listeners.
You're welcome. Thank you for having me.
When you enjoy listening to us, the best way to support us is by following us on your chosen podcast app. This could either be Spotify, Google Podcasts, Apple Podcast, Amazon Music, or the website of the Cognitive Science Student Journal. Another good way to support us is by following our Instagram account, which is called kaleidoscience_pod. On our Instagram account, you will also get regular information on the next episode. Thanks a lot for supporting us. This was Kaleidoscience, hosted by Elisa Palme and Sönke Löw, produced by Alina Ohnesorge, Elisa Palme, Sönke Löw and Sophie Kühne, produced in collaboration with the Cognitive Science Student Journal. The music was produced by Jan-Lukas Schröder. The logo was designed by Annika Richter. Thank you for listening and joining us on our journey through conversations on cognitive science.